Hello, everyone. I'm the host, Tracy. Welcome, everyone, to today's TinTin Meeting technology sharing session. First of all, let me briefly introduce TinTinLand to you. TinTinLand is a global Web3 developer community for builders, entrepreneurs, and enthusiasts by providing cutting-edge technologies, information, technical courses, seminars, hackathon startup competitions, and industry recruitment. We are committed to closely connecting community members to jointly build the future of Web3. TinTin Meeting is an online live broadcast program we set up focusing on the field of blockchain technology, inviting technical leaders in the industry to explore the practice and innovation of blockchain technology with everyone. With a deep understanding of CESS new definition in the field of decentralized data, various innovative solutions are emerging in the face of the growing demand for high-frequency dynamic data storage in the Web3 era. Today, TinTin Meeting will focus on the theme of building the future using access to implement decentralized solutions, and specifically invited Alex Liu, the head of developer relations at CESS Network, to be the guest speaker to discuss in depth the core content and technical highlights for CESS. So today you can see from the poster we have Alex will share with you the the topic, and after that, if you have any questions, you can record them and just drop in the comment area so I can forward to him later. Yes, so now I'll just jump into the sharing session. You can share the screen, Alex, please.
Yes, sure. Thank you so much, Tracy. Just give me a second. I'll share my screen. Okay. So, is my screen available? Visible?
Yes, yes.
Awesome. So, okay. Hello, everyone. This is Alex from CESS. I'm super happy to be here today, being a part of TinTinLand community. And I would love to welcome all of you to today's workshop on CESS Network Introduction. So hopefully after this session today, I'll get you guys a little bit more familiar with CESS, and then give you guys all the details about using the CESS DSS REST API. So some of you guys must have seen the agenda already. However, we'll start by exploring what CESS is, and then we'll provide a high-level overview of CESS network. We'll then dive into some of the details, like the challenges that are faced by the industry and the solutions that CESS provides. And then we'll quickly compare CESS with some of the other solutions, so you guys can better understand that why you should develop on CESS. And finally, to wrap up, we'll dive into DOSS, the Decentralized Object Storage Service, that actually acts as a gateway to the CESS network. So I'll end this session with a short demo, hopefully using the DSS REST API to show you all just how easy it is to start building with CESS. So without further ado, let's get started. So the first thing some of you might ask is, what is CESS? So in a nutshell, CESS is a next generation decentralized data infrastructure. It is designed to revolutionize data management and delivery. This distributed storage network is built on top of public blockchain. And we have our own millisecond high-speed content delivery network, which is also fully decentralized. In addition to that, CESS also empowers AI innovations through advanced Web3 protocols. It enables us to train AI models without exposing the original data itself. So what was actually the motivation for us to develop CESS? So one very good example I would like to mention is imagine when we upload our videos to YouTube. Like while it is convenient, we lose control on our data. They can modify our data. They can even use the data in ways we might not have thought about. And worst of all, they can actually remove the data completely. So CESS addresses like these issues by providing true ownership, data sovereignty, and control over our data. So this is what actually sets CESS apart from other solutions. With its innovative approach, CESS is able to deliver unparalleled data privacy, sovereignty, and scalability. So with CESS, you can retain control over your data and can ensure that it is handled according to your preference. So with that said, in this workshop, hopefully you learn how to how the CESS actually achieve all of this and how you can use it in your project. So let me start with the CESS architecture. So we'll start from bottom up. So at the bottom we have the blockchain layer, which serves as a distributed ledger for the entire CESS network. So it provides data storage, data ownership rights, smart contracts, and many other services. And it also plays crucial role in various consensus algorithm like proof of data reduplication and recovery, proof of idle space, uh, then proxy re-encryption, random rotational selection mechanism. So on top of this, we also have our own incentive mechanism that encourages all the storage nodes and other computational resources to join on the CESS network. So on top of blockchain layer, we have the distributed storage resource layer. This layer is users like virtualization technology to integrate and pool like storage and consensus like resources. So it is composed of consensus node and storage node. And consensus nodes are actually responsible for storing metadata, generating, validating transactions, and generating blocks. They also generate storage challenges for which storage nodes have to provide data storage proof back to the consensus miners. So they actually provide storage space to the network, then store users' data, and earn incentives for that. And on top of this, we have the content delivery network, which is fully decentralized once again. And this layer uses content caching technology to achieve like fast delivery of stored data, and is composed of cache node and retrieval nodes. So it combines the technologies of CDN and peer-to-peer technology for efficient access of the data. It reduces the number of proxy servers which are required and reduces the overall cost of retrieving the files. So the cache node actually, as the name says, it caches all the frequently accessed files, and the retrieval nodes actually helps in retrieving all the slices of our file from all the storage nodes. They assemble it and then sends it back to the user. And right on top, we have the interface layer, where we provide various tools like CLI, RPCs, APIs, and SDKs, and many more. So lastly, like CESS, at CESS, we also have XSS AI protocol suite. So the main component of this is CESS AI Link, which integrates federal learning mechanism. So this allows participants to train AI models with organizations without actually sharing the original data itself. So the private data remains private while we can still train AI models. So it utilizes smart contracts that delegates computational tasks to various nodes, which ensures efficient use of resources while maintaining data sovereignty. Yeah. So these are some of the challenges which is faced by the decentralized storage industry. To start with, first of all, we have the data vulnerability. So many decentralized solutions they mostly struggle with data loss due to either node failure or security breaches or some hacking attempts. So these vulnerability actually arises from distributed nature of these systems where data is spread across multiple nodes. So each of which could potentially fail or be compromised by hackers. So this makes users' data highly susceptible to loss or unauthorized access. So to tackle this, CESS has uh, high data assurance. This is by combining encryption with various fault-tolerant mechanisms. The data is stored through our proof of data reduplication and recovery mechanism, PODR square. This is our protocol. So the way it works is by slicing all the file into smaller segments and then encrypting it and then redundantly storing it into different nodes. So this ensures that file recovery can be done even if some of the slices are lost. Next, we have slow data retrieval. Most of the decentralized storage solutions provide like basic storage functionality without optimizing read, write, and network accessibility speeds. So, which leads to slow data retrieval, often caused by inefficient indexing and a lack of proper like search functionalities and all those stuff. So, CESS provides like millisecond data retrieval with decentralized content delivery network, which is which implements advanced indexing and caching functionality of frequently accessed data, which is cached to the nodes which are like closest to the user, which ensures rapid and efficient data access. Another major challenge is the inefficient use of storage space. And the majority of decentralized storage solutions fail to fully utilize available storage resources, which leads to a lot of wastage of resources. So this is because the system does not always have space maximization technology. So they cannot monitor the whole network's available space. So to address this issue, CESS implements smart space management or maximization technology. So our system optimizes storage resources, which ensures the available storage is used efficiently. So it works by keeping track of all the storage resources available on the network, like the available space, use space, and so on. And lastly, there's a very limited commercial use for the decentralized storage solutions. Mostly they lack advanced functionalities and integration capabilities. So without these support like those other solutions don't find it very useful for their businesses. So CESS offers a solution that is widely acceptable for most of the commercial users. We provide developer-friendly like RESTful APIs and SDKs in Go, JavaScript, Rust. And apart from that, we also support both the kind of smart contracts like the Solidity and WebAssembly smart contracts. So this makes CESS widely applicable for a wide range of applications. So this is another industry challenge, which is more specific to the content delivery network, to be more specific in the decentralized network. First is like the high costs. So many of the CDN providers requires like substantial initial investments, making it very costly for new businesses to deploy and maintain their services. So to tackle this problem, CESS promotes like free market for demand transactions, which significantly reduces the overall costs of the CDN networks. This is by because CESS uses P2P for CDNs, and anybody with their system can join the network and be a CDN node. And all the data which are closest to the users are stored with those nodes. And next, we have the data security risk, which are unavoidable. So data transfers across multiple nodes, which increases the potential for security breaches again. Like they can have unauthorized access because decentralized nature itself is it creates multiple points of vulnerability where data can be intercepted or compromised. So CESS implements advanced data privacy protection system through diversified security protocols, which safeguards our data during transfer and storage. So transmission and delays and network congestions during peak times, this further complicate performance and reliability of the network. So CESS also ensures optimal performance by dynamically adjusting the traffic loads, reducing transmission delays and network congestion during those peak times. Yeah. So the lack of standards and interoperability among different CDN providers adds another complexity which hinders seamless data exchange and integration. So CESS data sharing platform seamlessly integrates and can exchange data across different networks. So it's like it can integrate with different platforms altogether. Yeah. So lastly, many CDN services offer limited customization capabilities, like which restricts the ability of businesses to tailor performance and features to their specific needs. But where CESS provides highly customizable features that enables CDN enables those businesses to tailor CDN performance and features based on their specific needs. So this is the last like industry challenge, which is more related to the AI training in a decentralized network. So the first is, and the most significant challenge is the lack of data privacy. So during the AI training process, most of the time, highly sensitive information is shared across various nodes, which increases risk of data leaks. So this is because traditional centralized servers, they cannot guarantee complete data confidentiality when data is distributed from one training server to the another. In addition to that, this AI computation requires a huge amount of electricity and are very resource intensive. This is because AI training involves complex algorithms and extensive data processing, which consumes a significant amount of energy. So this high energy consumption not only impacts the environment, but also increases the operational costs. So the need for significant computational power actually also leads to monopoly of computing resources. Only entities with substantial infrastructure can afford to those hardwares which creates a barrier to entry for smaller organizations and researchers. And furthermore, the ethical and social impacts of AI results in unique and unequal like access to advancements, and also biases in algorithms, which creates additional layer of complexity. So CESS kind of addresses all of these challenges with its innovative CESS AI link solution. It's a Byzantium robust system with data privacy. So this allows for the training of AI models in a decentralized network without exposing the original data, like I said before. So preserving the confidentiality and integrity of all the sensitive information. So the key advantages of this is privacy. It is privacy preserving and provides decentralized computing, which is this is synchronized using a smart contracts. So the work is delegated through our smart contracts to each of the nodes for efficient use of hardware. Then we also have hardware acceleration and easy integration with our APIs. So let's explore like the detailed comparison of CESS between Filecoin, Arweave, and Amazon S3. So I hope like this comparison will give you all insight into like why CESS stands out as a superior choice for developers. You can, as you can see, CESS and Amazon S3 both have object storage service. Of course, CESS object storage service is fully decentralized, whereas S3 is centralized. And also, CESS DOSS also provides plethora of features compared to S3, like location-based storage selection, data ownership protection, and so on. And CESS also offers its own decentralized CDN network, which ensures fast and secure content delivery. So even S3 provides, but which is centralized once again. And Filecoin and Arweave don't have their own CDN services. Sorry. Then CESS also provides full CRUD operations, which is create, read, update, delete, same as S3, but in a decentralized fashion. And Filecoin only supports CRD, and Arweave supports create and read operations. And sorry, I can't see. Just again. Yeah. So CESS also supports LBSS, which is location-based storage selection. And Filecoin does not support its own, like it doesn't have native support to it. Arweave does not have anything like that. Amazon 3 gives an option for you to where you want to store your data. So for the proof algorithm, CESS uses PODR square with random challenges. Filecoin uses proof of replication and proof of space-time with challenges. Arweave uses success proof of random access, and S3 doesn't have any proof algorithm because it's a centralized server. And for data ownership protection, CESS provides very strong data ownership protection with various encryption mechanism. Now, whereas Filecoin kind of provide weak because it is mostly user managed. Users have to manage themselves. And for Arweave, also it provides a strong because it provides immutable permanent storage. And Amazon S3, again, it's a centralized and the data is stored in a centralized server. So it's kind of a strong ownership protection. Yeah. For disaster recovery, CESS provides a very high disaster recovery, which is guaranteed with proof of data reduplication and recovery mechanism. So CESS guarantees the availability of your data. And for Filecoin and Arweave, they kind of have like medium to high disaster recovery. Because in Arweave, most of the data is stored on chain. So if any node goes down, the other chain still have the data. Whereas Amazon S3 has various replication mechanism like cross-region, same region, and so on. But this incurs additional costs to the users. And for the retrieval speeds, says like we have tested that when you upload and download files, the speed is as fast as Web2 in milliseconds. Same like Amazon S3. whereas in Filecoin and Arweave, it's kind of relatively slow. And storage costs on CESS is around like almost $1 to $2 per terabyte per month, whereas for Filecoin it's kind of low, but it's still expensive than the CESS. And for Arweave, it is kind of like $4 to $10 per terabyte per month, whereas Amazon S3 is like extremely expensive, which is around $21 to $24 per terabyte per month. So for payment rules, CESS on CESS, you just have to pay to rent the storage space. Same in Filecoin and in Arweave, the rest. But in CESS, retrieval is free. You can retrieve the files without any cost, which is same to Arweave. And for Filecoin and S3, you have to pay even while you retrieve the file. So for capacity, like in CESS network, we have around 45 petabyte of storage right now in our testnet with around 6,000 storage nodes. And in Filecoin, there's like more than 5 exabyte of storage, which with around 2,200 nodes. And Arweave has around 300 something a petabyte of storage with around 100 nodes. And Amazon S3, again, it's a centralized storage, so it's not applicable to it. So to utilize the services provided by the whole CESS network, we need to understand DOSS, which is Decentralized Object Storage Service. So it simplifies storage service for developers and offers HTTP API for object-based storage service that is low cost, secure, and highly scalable, making it an ideal solution for handling unstructured data. So DOS actually serves as a gateway to the CESS network, which uses blockchain-based distributed storage protocol. And it serves as a Web3 platform for catering to developers, offering capabilities which is comparable to decentralized AWS S3. And you can say like DOSS is the next generation S3 or Google Cloud of Web3. So it is a fast access portal for the CESS network designed to provide low latency and high throughput. And it offers a convenient platform for application development, like authorization management, custom development capabilities, and most importantly, ensures that data ownership remains with the user. So why should you use DOS? So DOSS actually provides a comprehensive suite of features, making it an attractive choice for a broad range of applications. So it provides comprehensive HTTP APIs and SDKs, which makes integration effortless. And one of the standout features of DOSS is its location-based distributed data storage service, which provides data storage and access based on the geographical locations. So it is designed to be highly scalable. It provides lightning fast data access. And it also provides robust mechanisms for data privacy and data authorization, like access control, which ensures sensitive information remains protected. So you can store a wide range of data on through DOSS, like NFTs, DAs, digital assets, backups, images, videos, images, and so on. So with DOS, you can guarantee user remains they retain a complete ownership and sovereignty of their data, which is free from potential risk, which are associated with centralized servers. And lastly, it is also compatible with IPFS. So before I showcase the DOSS REST API, I would like to show you guys the workflow of the DOSS. So we can actually break down the workflow in 3 key steps. First is like depositing CESS tokens, then purchasing some space and authorizing the gateway, and lastly performing the upload and download operations. So the first thing we need to do is to get some CESS tokens for which can be obtained through our CESS faucet for testnet. And for mainnet, you can either buy or claim your CESS tokens through various events. So then you can start purchasing space. It can be done either through our CESS Explorer, Blockchain Explorer, or the SDKs or APIs. So the easiest way to use CESS is to use the Blockchain Explorer. We'll see in this demo how we use it. And the amount of space can be purchased in gigabytes, so which can be rented for like 30 days. So once we have all those things done, oh, sorry. Okay. And then we authorize the gateway, and then we can start uploading the files. And the DOSS handles like starting the files, distributing it amongst storage nodes. So we'll see all of this in the demo. So for there are two main prerequisites. Like first of all, you'll need a CESS wallet account, and then you'll need like one of the DOSS gateway addresses. Okay. So if you're interested, you can also host your own DOSS gateway. The documentation is linked over here. So let's get started. Enough of theory, I guess. You guys must be bored now. So let's upload some file now. So first of all, what we need to do is I already have a CESS wallet account with some CESS tokens in it. So we'll authorize the gateway first and purchase some storage space. So I'm going to go to developers, extrinsics, select the account from which I want to send the transaction. From here, we'll select OSS, that is Object Storage Service. And then authorize. I'm going to authorize the Singapore address, which is closest to my location. I'm based in India. Okay, so I'm just going to sign and submit the transaction. Okay. So once the address is whitelisted, we can go to change state and query this from OSS. Okay. OSS authority list and select the account. You'll see all the authorized gateways here. And the next step is to purchase some storage space. For that, we'll have to go to extrinsics again. And from here, we'll select storage handler. And we have function called mint territory. Mint territory. So to purchase a space on CESS, you'll have to purchase a territory. We call it territory in CESS. So I want to purchase like 5 gigabytes of territory. We'll give it a name. We'll give it like TinTinLand. And the number of days I would like to rent is for minimum 30 days. Just sign and submit. You can also query it from change state. So I've already done these 2 steps. Now the next step is to generate authorization keys for the DOSS so that the DOSS server knows who is actually requesting those APIs. So for that, we need to generate an identity signature, which we can do it from here. Again, from the Explorer, go to sign and verify, enter any random message. I'll just enter hello and sign in. So this will throw up a signature. And then we'll need this signature to send all of our requests to the server. So we'll start with uploading a file. So this is our uploading file REST API with the put method. and it accepts three headers: bucket, territory, and cipher. A bucket name, territory name, and the cipher. If in case you want to encrypt your files while uploading to the CESS network, you can use this field. So this is the command which I have already written here to save the time. And I'll just open the terminal. I have a file over here which is called hello.txt. So I'll just show it to you. Hello TinTinLand. And I'll just upload this file to the CESS network. So signature we have replaced with our signature, then account from our account address, and the message which you use to sign our message. Then the territory, I'll change it to TinTinLand. And bucket, we can write any random bucket name. We'll send it as a plain text, and the file name, and the Singapore address with the file endpoint. So the moment we'll post this, it will return us with a file ID. Yeah, so this is the file ID. We can again query this using the APIs or SDKs, but I'll show it with the Explorer. So over here we can select file bank, and then we can select deal map. Because this file is not being sent to all the storage nodes yet, so we can find it in deal map. Otherwise, once the file is already distributed, then we'll find it inside file function. So here you can see all the fragments of our file. So these the file is actually fragmented into smaller segments, and then this will get distributed to different storage nodes. So each of the file which will get distributed will be able to see the status over here. So similarly, we can actually download the file using the download URL. And if you would like to integrate this in your browser, you want to show your images to your browser, you can use open function like to preview the file. And we also have like many other functions like delete file, delete bucket, and various other functions. So I hope this give you all insight in how to use DOSS and integrate it with your project. And lastly, I would like to just go through a quick roadmap. So we started in 2019, and we designed our prototype of a decentralized cloud network. And currently, we are in our final testnet version 7.8, which is named Venus. And we also propose our standard, IEEE standard, which is 3233, which is accepted. And now we are working closely with the working group with various IEEE members to make the proper decentralized storage protocol standard. And we are also planning to launch our mainnet this year. So, there's many exciting things we have in our plans down the road. So please feel free to check out. So I hope you guys have an idea on how you can utilize CESS and integrate it with your project. So we also offer SDKs, like I said, in Go, JavaScript, as Rust. If you guys are interested, please feel free to reach me out on Telegram, Discord, or Twitter. I'll be happy to help. Thank you so much.
Thank you, Alex. We got one question. The question is asking how does CESS differentiates itself from other existing centralized storage solutions like Filecoin, Rwave, especially in AI and high frequency data storage? Like, what's the difference between CESS and other decentralized storage solutions?
Okay, so if you compare it with other centralized or decentralized storage services, CESS actually provides Web 2 performance, even in Web 3, because we have our CDN network, which is also completely decentralized, which again runs on peer-to-peer technology. So we are able to manage to reduce the price for like accessing or uploading, utilizing all the services on our network. And whereas if you compare it with Filecoin, Filecoin is kind of very slow right now. So it is like kind of not acceptable for most of the projects. And again, like Amazon S3, like or any others centralized services, if you guys would use, the data actually is owned by the server itself. We don't have control on those datas. So they can monopolize, they can use, they can do whatever they feel like with your data. So this is how like CESS is trying to like uh, provide the best services in the decentralized, uh, yeah, Web3.
Okay, then I guess now there's no more questions. I'll just quickly share my screen. Okay.
Yeah.
Wait, just give me a second. Share. Okay. So yeah, thanks for the answers, Alex. So today's TinTin meeting technical sharing session has come to the end. If you have any questions, you can follow CESS X, Discord, Telegram, and you can also follow our. You can basically just scan the QR code from the most left-hand side. Yeah, and we have a lot of other events coming. So thank you for the guests and friends for your active participation. I'll see you next time. Thank you, everybody.
Thank
Bye-bye.
you so much. Yeah, bye bye.
Bye.